In this problem we have kids playing marbles. Marble A is thrown at marble B and they bounce off at different angles. Marble A is 21 grams, marble B 17 grams. Initial velocity of marble A is 3.8 meters per second, marble B is at a standstill. Marble A goes off 32 degrees above the x-axis, marble B 22 degrees underneath the x-axis. We want to find the final velocities of each. Conservation of momentum, we do it in each separate direction. So we have to do it in the y direction and the x direction because this momentum is a vector quantity. So let's do it in the y direction to start. Y direction. Initial momentum in the y direction is 0. Because the only thing moving is A and it's only moving in the x direction. Right, if we define y is up and x is this way, we have no y-directed motion. So we can just say 0 equals, now final momentum is mass of A, velocity of A final, plus mass of B, velocity of B final. And these velocities have to be in the y direction, since we're doing this for the y direction right now. So we can't just put VAF, we have to put MA. VAF is going to be sine 32. It's going to be VA final sine 32 degrees. So this should actually be VAF y and VBF y plus mass of B. VBF y is VB final times sine of 22. And we notice that this is in the negative direction, so what we have to do is write it as a negative. Since it's going in the negative direction, this is going to be a negative momentum. So this is equal to 0. What we can do is we can solve. So we can plug in for M and MB and solve for, let's solve for VAF. So we'll have VAF equals, so I add this to the other side, mass of B is 17 grams, which is 0.017 kilograms, and VBF sine 22. So I added that to that side, now I have to divide by the mass A and sine 32. So mass of A is 0.021 kilograms times sine 32. Multiply that out, and that gives you an answer of 0.57226. VBF. So that's VAF in terms of VBF. So now what we have to do is do this in the x direction, and we can plug this in to solve. So x direction. So we have initial momentum is MA V naught A, which we know we can calculate. Equals MB V V naught B in the x direction plus MA V naught A in the x direction. So we have mass of A, which is 21 grams again, 0.021 kilograms, V naught A. Oh, V naught A we know, so we'll plug that in too, which is 3.8 meters per second, equals mass of B, which is 17 grams, 0.017 kilograms, times V naught Bx. So if we want to put this as the x component, why don't we write it out in terms of the total, which is going to be cosine 22. So it's going to be V naught B cosine 22 degrees. Then we do that add on plus mass A, which is 0.021 kilograms, times V naught A in the x direction, which is going to be cos 32. So that's V naught, sorry, this is V final. This is V final on this side. I wrote that wrong. V final. V final. So V final A times cos of 32. Okay, and what we have is we have VAF in terms of VBF. So I multiply this times this, and that gives me a number of 0.0798. 0798 equals, and 0.017 times cos 22 is going to give me 0.015762. 0.15762 times VBF. And this one I have plus 0.021 cos 32 times VAF, or VFA. And it's this, 0.57226 VBF. 0.57226 VBF. So now I can multiply this times this, get just a number times VBF, and add these two up algebraically, which will give me 0.0798 equals, those added up gives me 0.02595 VBF. Solving for VBF by dividing out 0.02595, VBF equals 3.08 meters per second. And this is after I round off to 3 significant digits. I plug this to VAF, what's in my calculator with all the rest of the decimals. Before I round off, I want to add that in here. And that's equal to 5.7226 times 3.08 VAF equals 1.76 meters per second. This is 0.76 meters per second.